So 2018, number 1. In the real number system, the inverse of addition is represented by, we know the inverse of addition is subtraction, but we have to be very fine-tuney when it comes to questions like this. The only question that will line up with this particular property is going to be B. Right? That one is a no-brainer. Let this be equal to 0. Given that f of s is 0 and f of minus r is equal to 0, which of the following equations are true? So if f of s is 0, then x minus s is a factor. If f of minus r is equal to 0, then x plus r is a factor. And because I'm getting a cubic, I need to multiply these two linears by another linear. And in the 4 options we have, that other linear is represented by ax plus p. So we are bothering with looking at these things. I am looking for a x minus s and a x plus r. X minus s, x plus r, I'm going to get a to be my answer. The square root of x minus y minus root y over root x plus root y. So let's go ahead and rationalize. We will be rationalizing the denominators first. Check and see if that works. If that doesn't work, I'll just try to rationalize the numerator. So root x minus root y over root x plus root y multiplied by root x minus root y over root x minus root y. The denominator is going to be a difference of two squares, where I square the first term, root x squared is going to be x, take away, and I square in the second term. So again, x minus y on the denominator. So one time it's looking like a or c. And then the top is root x minus root y all squared. If you want to go ahead and multiply it out, root x into root x minus root y, no sin. From here, I can shortcut this. Root x squared is x, take away 2 root x root y plus y. Root x root y can be combined as root xy. So x take away 2 root xy plus y, c looking like my answer. And you'll realize this question is going to be repeated a lot. Given that x is less than y, and both are the real numbers, which of the following expressions is true? Now, the only thing we can do here is test all of these here to see which one is true. And for questions like this, where they're asking you, well, which one is true? My advice is, once you're testing it, test it in all, because you could have make a mistake with one of them. Get a false truth, and the real truth somewhere on the underneath. So, x is less than y. So, if x is less than y, I'm going to take one thing into consideration. Both x and y are positive. And I'm going to say there is 0. Let me say x is 2 and y is 3. And I'm going to test this in all 4. Minus x, which is going to be minus 2, is that greater than the modulus of 3? No, it's not. Over here, I'll get minus 2 is greater than 3. That is working out. Next is modulus of x, modulus of minus 2. Is that less than modulus of modulus of 3? Modulus of minus 2 is 2. Is that less than 3? It is indeed less than 3. So be looking good. Be looking good. But we still have to test the rest. Because you see this modulus business? Negative numbers have a big part to play when we're doing questions that involve the modulus, especially like this. So, part B looking good so far. X minus y, 2 minus 3 is the modulus. Well, over here the modulus could never be less than 0. So I know that how this can work. Over here, this is also viable. So D is also a viable option. So which one it's going to be, B or D? Well, I actually have another case where I can test for x and y. I can say x is minus 3 and y is minus 2. because they say that our x had to be less than y, which means x had to be somewhere on the left-hand side of the number line. So let me test back these two. Is the modulus of minus 3 less than the modulus of minus 2? Is 3 less than 2? So you're going to get a false positive for the option B. But really and truly, the answer is going to be D. Now, one time you can also look at these here and know that how this will forever be positive regardless of what number x and y takes. And you can just go ahead and select D to be your answer. But I just had to show you all how we break it down. All right, not P and not Q is logically equivalent to, all right, so in this one here, we can use either a truth table or we can use the algebra of propositions. For cases like this, boy, I don't like to use the algebra propositions. I don't even learn it. All right, so we're going to dive into a little bit of truth tables. So watching it, we're not really going to use any algebra of propositions. All I'm going to do is remove the bracket. Not P and not Q is literally not P and not Q. It's a no way I could simplify that more than what it done simplified already. All right, next. Given that x and y are negative numbers, x is greater than y. So I'm going into my number line again. I go in here, x and y are negative. That is 0. Let me go it again, minus 3 and minus 2. X is more than y. So this had to be x and this had to be y. We had to go and test in all of them. Cool? Let me test option E. Is x squared greater than y squared? Is minus 2 squared greater than minus 3 squared? Nope. Is x squared less than y? Is minus 2 squared less than 3? Nope. Is x greater than y squared? Is minus 2 greater than minus 3 squared? Nope. And is x squared less than y squared? Yep. Cool. Ooh. Now some of us are going to just plug this straight into our calculator, right? And we can definitely do it. Let's do it. Oops. Because in the question we have log without any base, I know that I logged the base 10. But I know some of you had them fancy calculators where you can literally input any base in the mix. So let me go. Log 15 take away log 6 plus log 4 over 25 raised to the power of a half, or we could say 0.5 log, open brackets, 4 divided by 25, close brackets, 0. The answer is 0. Bam shot. Number 8. The cubic equation whose roots alpha, beta, and gamma satisfies the following conditions. Alpha plus beta plus gamma is minus 2/7. Alpha beta plus alpha gamma plus gamma alpha is minus 1, and alpha beta gamma is negative 3/7. So we want the cubic, right? So we know it's going to be x cubed minus the sum of the roots, minus 2/7 x squared, plus the sum of the product of each pair, which is minus 1x, minus the product of the roots, which is minus 3/7, is equal to 0. I'm going to fix it up. I'm going to get x cubed plus 2/7 x squared minus x plus 3/7. Multiply everything by 7. 7x squared, sorry, x cubed plus 2x squared minus 7x plus 3. Let me check and see. I can zoom in a little bit more so you can see it a little bit clearer. Alright, so 7x cubed, all is 7x cubed, we're looking for a plus. So it's either here and here. Then we're looking for minus 7x. Nice. Minus 7x here and minus 7x here. Then we're looking for plus 3. Plus 3 is here. So the answer is E. Which of the following mapping diagrams does not represent a function? So the first test we are going to take is a vertical line test. And if we cut the function more than once, it's not a function. Ram, cutting twice, not a function. The value of 36 to base, log 36 to base 6 is, again, some of you could plug this into our calculator. I'm going to say, well, here was the scene. I know I'm going to use change of base. Log 36 to base root 6. I know that is equal to a number. I'm going to say why. I'm going to use laws of indices by changing this to exponential first. I'm going to get root 6 to the power y is equal to 36. Root 6 is 6 to the power of a half. So I'll get 6 to the power of a half y is equal to 6 squared. A half y is equal to 2. And y could be 4. The answer is C. Which of the following statements is true? So part A, that could never be true because you could test it, right? Let me go ahead and expand. Let me just expand for the first two terms. I'm going to get on the left hand side 1 squared plus 2 squared. Let me go up to 3 squared. Is this equivalent to 2 into 1 plus 2 plus 3? Never. Let's look at the second one. I'm going to have same thing, 1 squared plus 2 squared. I'm just doing the first three terms. Plus 3 squared. Is that equal to 1 plus 2 plus 3 all squared? Well, no, it's not. You can test it and see. This 1 plus 4 plus 9, which is 15. What number squared going to give me 15? Think about it. So that can work as well. What about r squared? Alright, so again we're going to have 1 squared plus 2 squared plus 3 squared. Is this equal to, now the second summation, if I can't notice it, it starts at r is equal to 0. So I'm going to have 0 squared minus 1 plus 1 squared minus 1 plus 2 squared minus 1. I'm going to go up to the 3 plus the 3 squared minus 1. Well, I'm going to get the 15 here. I'm going to get minus 1 plus 0 plus 2 take away 1, 4 take away 1 is 3 plus 9 take away 1 is 8. 8, 9, 10, 11, 11 take away 1 is 10. So, nah. So, I know the answer is D. I just showing all how well I got tested through, right? Now, D, using laws of summation, I can split up the 2 and I can split up the r squared. When 2 goes from 1 to n and r squared goes from 1 to n, we already get this piece here. This piece is this piece, right? When I expand out the summation. But is this equal to 2n? And the answer is yes. This is equal to 2 into, but it's 2r to the 0, right? So I'm going to put that here, 2r to the 0. This is 2 into 1 to the 0 plus 2 into 2 to the 0 plus 2 into 3 to the 0. All of those powers of 0 will give me 1. So I'm going to get 2 plus 2 plus 2 plus 2 n times, which is going to be 2n. So the answer for this is D. And you all will see how this repeat question keeps coming up. And we're just going to know what the answer is. Alright? Alright, number 12 is one that we have to be very careful when we are looking at it. The value of G inverse f of 3. Before we dive into the answer, let me try and read the table properly. The table says f of 0 is 7, f of 1 is 5, f of 2 is 3, and so on. G of 0 is 3, g of 1 is a quarter, g of 2 is a half, and so on. So I'm looking for G inverse f of 3. First, let me figure out what f of 3 is. F of 3 is going to give me 2. So I'm looking for G inverse of 2. Not G of 2, eh? G of 2 gives me a half. G inverse of a half gives me 2. So G inverse of 2 gives me 5. This is a very common repeat question we have here. The values of x that satisfy the inequality, the modulus of 2x minus a is greater than the modulus of x when a is greater than 0 are. Two ways we can do this, right? We can either, more than two ways. We can square both sides, we can rearrange, or we can use the definition for the modulus function. So let me go with modulus of 2x minus a is greater than the modulus of x. Let me square both sides. When I square, I'm going to get rid of the modulus. 2x minus a squared, I'm going to say is equal to x squared. Then we go in and have, bring them across to get a difference of 2 squares. I'll get 2x minus a all squared, take away x all squared is equal to 0. Difference of 2 squares, first term take away second term, 2x minus a, take away x, now my first term, multiplied by first term plus second term. 2x minus a plus x is equal to 0. 2x take away x is x minus a. And 2x plus x is 3x minus a is 0. Again, x is a, and again, x is equal to a over 3. Now, a over 3 is the smaller number, right? Now, I want to know where the graph is greater than. Cool? I didn't change the direction of the sign coming down the road. If I wanted to keep the greater than sign coming down the road, nothing will influence that greater than sign changing to a less than sign. So I know I'm dealing with greater than, which is above, and I know I'm dealing with a positive x squared. So I know I'm dealing with here and here. This is my a over 3. This is my a. It's going to be x is less than a over 3 union x is more than a. So x is less than a over 3 and x is more than a. Now, you see how I have or here? The only one that lines up is a or. That's the only one that lines up for this particular range of values. Union means and. Alright? So I will say that on number 13, it have a little bit of miscommunication or misinformation when it comes to the words in between them. All right. That's the best I could tell earlier. But once all you're comfortable with the two sets of values, don't let the sign, the word in between influence all the question too much, or the answer too much, because it's supposed to be and not or. But I know that always x is less than a over 3 and x is more than a. Right? That's all I have to say about that. The general cubic equation, whose roots alpha, beta, and gamma may be written as, well, we know is x cubed take away. So all a, b, c, d working. So it's take away, then plus, then take away. So I see a takeaway, a plus, and a takeaway. I'm just gonna double check, right? You can just check the rest. Takeaway, nope. Takeaway plus, nope. So the only answer is going to be B. Takeaway plus takeaway. Alright, our next one here, number 15. The statement this is logically equivalent to. Now, in this particular case, if all you want to use De Morgan's laws, all you could use it, but it's little time consuming because we have to use, I believe, De Morgan's laws twice. Then we have to use the contradiction law and I believe the identity law as well. So we might have another law to use inside of there. And like I said, I don't know how much teachers actually teach that, but I don't really fight up with that. So what I'm gonna do for questions like this in the past papers, I just gonna tell you what the answer is. And fingers crossed, we're gonna hope and pray a repeat comes. Alright? So for this one here, the answer is going to be D. Right, so we hoping and praying. You could also draw the truth table for this, all right, and see what the output is going to be. And granted that this is the first paper we are going to do, let me go ahead and do that, right? Let me show you how I just approach these questions in the form of a truth table. So we're going to have P, we're going to have Q. True, true, false, false. True, false, true, false. Let me get not P in the mix. False, false, true, true. And let me get not P and Q. Sorry, yeah, not P and Q. So not P and Q is going to be true here alone. Everywhere else is going to be false. And then we're going to have P or not P and Q. So P or this, we're going to get a true, a true, a true, and a false. And not that is going to be not P or not P and Q is false, 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 true. And what I'm going to do for questions like this, you're going to test each of the options by creating a truth table for them and seeing which one gives us false, 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 true. So I'm going to show you all that not P and not Q going to give us a false, 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 true. Not P is going to be false, false, true, true. So not P and not Q is going to be false, false, true, true. Oh no, this is not P, sorry. I have not P already, my bad. I'm looking at not Q now. Alright, so I will just squeeze in not Q here, right? Not Q going to be false, true, false, true. So when I OR these two here, I'm going to get false, 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 true. Alright, which is logically equivalent to that. That is how I approach these kinds of questions. But this is time consuming. So let me again hope and pray a repeat question comes. A circle is defined as this and that. The gradient of the normal to the circle at 0, 0 is. Alright, so this one is not as difficult as you might think it's going to be. Or you might want to go through implicit differentiation and rearrange, and nothing wrong with that, right? That is actually a good suggestion. But let me make sure me am mixing up unit 1 and unit 2, right? I usually show AdMath students how to implicitly differentiate. So remind me earlier, is implicit differentiation? No, we didn't. Okay, so we don't know how to implicitly differentiate, but you could still use it, right? So let me go through the method of rearranging and differentiating. I'm gonna solve for y. So I know that how y squared going to be 4 take away, and I'm gonna expand the bracket. 4 take away the x squared, and I'm gonna have to take away, what is that? 4x, and I had to take away 4. Cool? Like y squared. And 4 minus 4 is 0. So y is going to be the square root of minus x squared minus 4x. And I have no seen with that. Y is equal to x squared minus 4x to the power of a half. Let me go ahead and differentiate. The y dx, or y prime, is a half into x squared minus 4x to the power minus a half multiplied by the differential of the bracket, which is 2x take away 4. I going to fix nothing. The gradient of the normal to the circle by plugging in the value of x inside of here, again the gradient of the tangent. So at x is equal to 0, the gradient is equal to, I'll get 0 here, 0 here. So this whole thing turns to 0, which is multiplication, and this whole thing turns to 0. So this here tells me when the gradient is 0, we have a horizontal line. This is the gradient at the tangent. So which means the tangent is a horizontal line. The normal is perpendicular to our tangent, so the normal going to be a vertical line. And a vertical line has an undefined gradient. Answer is E. The value of sine of pi on 2 minus p is, I could learn off the identities for this, or we can just go and use our compound angle formula from ADMATS, which is sine pi on 2 cosine p minus cosine pi on 2 sine p. One of them gonna give me 0. Let me check and see. What is pi on 2? That 90 degrees. And sine of 90 degrees is 1. Now my calculator in degrees, so I'm just leaving it there, right? That was putting that. So sine of 90 degrees is 1, so this is going to be cosine of p. Take away. I wonder where's cosine 90 by? That is indeed 0. So you go away. So this is going to be cosine p. Alright, so we're cooking with gas so far. The line through the points P and Q is parallel to the line with equation that the value of K is. Alright, so we want to get a gradient here. Alright, once I see parallel lines, I know a property of parallel lines is their gradients are the same. Yes, so I'll go on and say, well, sir, our next property of parallel lines is they just never meet. That property not going to be used in this calculation. So let me get a gradient of this particular line here. So y going and be, move the 3x. So one time, that is my gradient. Me and bottom with the 21. So minus 3 is the gradient. Let me calculate the gradient of p, q. x1, y1 and x2, y2. y2 minus y1 over x2 minus x1 is equal to negative 3, because that's the gradient. The parallel lines have the same gradient. 8 take away 2 is 4. It's equal to minus 3 into 6 minus k. 6 3s are 18. When I move the minus 18 across, I get plus 18. 4 plus 18 is equal to minus 3 by minus k is 3k. 18 and 4 is 22 is equal to 3k. And k is 22 over 3. No, that doesn't make any sense to me. Let me see if I make a mistake somewhere. y2. Oh, yeah, y2 minus y1. So 8 minus 2, 6 minus k is equal to minus 3. It's parallel to the line with the equation. So when I move the 3 across, I become minus 3. Right? So minus 6. Right? So 6 3s are 18. Oh, 8 take away 2 is 6. Sorry. Right? 8 take away 2 is 6, not 4. Right? So I can make life a little bit easier here. Divide both sides by minus 3. Minus 2 is equal to 6 minus k. Move the k, move the 2. K is equal to 6 plus 2. 6 and 2 is 8. C is the answer. The gradient of the straight line perpendicular. Oh God, what should I do this now? Perpendicular. Lord Father. Alright. Perpendicular to 3x plus 2y plus 4. 2y is going to be minus 3x. Y going to be minus 3 over 2x. I'm not bothering with the constant because I'm dealing with gradient. Then the gradient of this line, perpendicular, flip, change the sign, positive 2/3. Miss Gan will be very disappointed with how Cape would have done this question. Just saying. A curve is defined by the parametric equations that the Cartesian equation of the curve is a substitution game. Let me solve for t. Over here, t is equal to y minus 2 plug in t over here. X is equal to 3 plus 2 into y minus 2. I move this up. Expand. 3 plus 2y minus 4. So I just browsing through here as I do the working to see which one of the equations I'm going to have to put it in the form. I see an x and the y is on the left hand side. So let me do that. X minus 2y is equal to 3. Take away 4 is minus 1. So x minus 2y is minus 1. D is the answer. The value of theta, or what value of theta between 0 and pi satisfies the equation this is equal to 0? Now, it have the easy way and it have the easier way. The easy way to do this is to go ahead and solve the equation. The easier way to do this, plug in theta is pi on 6, see if it's working. Plug in theta is pi on 4, see if it's working. Pi on 3, pi on 2, and see if the equation working. So let me show you what I mean when I say that. Remember, cos squared theta is the same as cos theta squared. So let me just change my calculator in radians. 2, open brackets, cosine of pi on 6, all squared, plus 3, cosine of pi on 6. I'm not going to put the minus 2 for a good reason. I'm going to move the minus 2 on the right hand side. So it's less things I have to plug into my calculator. If I wanted, I could have put in the minus 2 in my calculator here to make my equations a little bit longer, but I ain't no seen if you do that. I am looking to see if this value here is going to give me a positive 2. Because 2 cos squared theta plus 3 cos theta will be equal to positive 2. I get positive 2. Oh, sure, yeah. I put it squared. Now instead of pi on 6, I'm going to try pi on 4. See if that working. Pi on 4 and pi on 4. That is working as well. Let me try pi on 3. Pi on 3. Pi on 3. Aha! This one working. So the answer is going to be C. And this is a lot faster than solving the equation. Alright, the expression cot x plus tan x can be written as, so watch what I'm going to show you here again. In terms of trigonometric identities, number 22 telling me that how cot x plus tan x have the same numerical value as one of these options. And these kinds of identities works for any value of x you can think of. Any angle you plug into cot x plus tan x, and we plug in that same angle in one of the options given, I'm going to get the same exact number. So what I want all to do for questions like this, pick a real random value of the angle. Let me just say, I just make up an obscure, real, non-coincidental angle that might give you two answers. So I'm saying x is 0. Now let me go with 9.731. That is a real random out there number. Cot x is 1 over tan. Cool? So I'm going to go with 1 over tan of 9.731. I'm pressing equal to get the value of this. And then I'm adding this to tan of 9.731. Again, 3.4790533. I'm writing that down. 3.4790533. 2 cosec 2x. Now cosec is 1 over sine. Cool? So 2 cosec 2x is 2 over sine 2x. I could go ahead and plug it in there. I know this can't work because I have a cosine of y there, so that can't work. But I think D might be able to check a little easier. Alright? Let me check and see if D easier to check. Remember, x is 9.731, right? 9.731. I'm going to do something that my calculator allows me to do, and everybody calculator, I believe, has this same function. I'm going to store this value as a. So I'm going to say sine a minus cos a, sine a minus cos a, that's my numerator, divided by sine a cos a. Okay, so that's not working at all, right? So it have to be either A or B. Let me check B. 2 cot 2x. So that's 2 over tan 2a. So 2 divided by tan 2a. I again that, so let's check A. That is 2 divided by sine 2a. 2 divided by sine 2a. I end up getting the same thing there. Alright? So the answer is indeed A. Alright? So let me just point out one thing to you guys. I know that how some of them might say, well, sir, I know what he doing, why he just didn't check it in the first one. I know the answer was A, but I just wanted to show you all how to utilize the method by plugging in the angle in here. We know we can plug in the angle here because I have a Y, and by plugging in the angle in here as well. Right? I just showing all you how to do it to make sure you're comfortable doing it. I just putting that out there, right? The minimum and maximum values of this are so by so and so by so. Alright, so it really has no shortcut we can use for this other than starting with is sine theta minus 1 less than or equal to sine theta less than or equal to 1. Are you still here, Emma? Just checking. Thank you. Alright. So I want to get 2 plus sine theta. So I add in 2 everywhere. So minus 1 plus 2 is going to give me 1. Less than or equal to sine theta plus 2. Less than or equal to 3. And I flip in every single part. So 1 less than or equal to 1 over sine theta plus 2 less than or equal to 1/3. But my smaller number needs to go on this side. My bigger number needs to go on this side. So the smaller number, which is the minimum, is going to be 1/3. And the maximum is going to be 1. So the answer for this is C. The vector u has a magnitude 4√5 units and is parallel to the vector v, which is I minus 2j. A unit vector parallel to u is, so if the, this is an easy one, man. Here what you can do here, right? They want a unit vector parallel to u. First things first, just check and see which one of these things here gives me a magnitude of 1. So let me check it now. We have the calculators. I'm going to expand it mentally and then square the I, square the j, and I'm supposed to get 1. Alright? So I'm going to get root 5 on 20 squared. Okay. Root 5 over 20 all squared. Oops, forget to open brackets. Root 5 on 20 squared, and my I component, plus, open bracket, root 5 on 10. Root 5 on 10 squared. A is not a unit vector. What about 4 over root 5 squared? 4 over root 5. 4 over root 5 all squared plus 8 over root 5. 8 over root 5 all squared. Nope, that's not a unit vector either. This is not a unit vector for sure. 4 root 5 squared plus 8 root 5 squared is not going to give me 1. What about 1 over root 5 plus 2 over root 5 squared? Check that and see. Open brackets 1 over root 5. 1 over root 5 squared plus 2 over root 5 squared. This one gives me 1. So this here is the only vector that gives me a magnitude of 1. And they're asking for a unit vector. Alright? Other than this, if they ask us for a next way to do the question, or they didn't ask for a unit vector, but they asked for a vector parallel to u, all you had to do is figure out which one of the options is a scalar multiple of I minus 2g. The curves intersect at 3 points. The y-coordinates of these points are some simultaneous equations we're lining up to do here, right? Now, in these simultaneous equations, I want to solve for y first, because that's what the question asking me for. So I'm getting rid of all the x's. So x is equal to 6 over y. And I'm substituting that inside of here. So y squared is equal to 6 over y plus 7. Y cubed is equal to 6 plus 7y. So y cubed minus 7y minus 6 is equal to 0. I show all the calculators. So, well, or everybody calculator supposed to be able to solve cubics. My one is, mode 2, 3. A is 1, B is 0, C is minus 7, and D is minus 6. The answers are minus 2, 3, and minus 1. D is minus 6 here. Minus 2, 3, and minus 1. Oh, A is the answer. I didn't see the minus 1 inside there. Alright, cool. Alright, so 1 plus cos to the power 4a minus sine to the power 4a is equal to. Remember not too long ago, in the near distant past, in number 22, we assigned a value for the angle. I'm going to do the same thing here. I already have 9.731 as my random number. I already have that stored in my calculator as A. And here's the proof. Recall A. Oh, I took off my calculator. 9.731. Store that in A. Cool. 1 plus cosine A to the power 4. Open brackets. Cosine A raised to the power of 4 is equal to that. And I had to take away, open brackets, sine A to the power of 4. Again, 1.8182 45438. I just writing the whole thing just in case, right? Alright, so let's check and see the first option. 2 cos squared A, so it's going to be 2 open bracket cosine A squared, open brackets sine A squared. It's not going to be that. 1 plus cosine 4A, 1 plus cosine 4A. It's not going to be that. Cosine 2A, 0.81824. Alright, so it's not that. It's obviously 1 point. And cosine 2A also 2 cosine A, 2 open brackets, cosine A all squared, 1.818245438. So D is the answer. So you see how close cosine 2A was to the answer, and that might make you kind of second guess yourself. but have confidence in yourself to know the one I calculate is 1 point and not 0 point. So, right? The general solution for sine 2 theta is equal to sine pi on 6 is. Now, this is one of the topics that teachers does not want to teach. Some of the teachers just forget to teach it. So, I'm going to go it over for everybody's benefit, right? So, general solution. If sine 2 theta is equal to sine of pi on 6 and a 1 theta, 2 theta is equal to n pi plus minus 1 to the power n sine inverse of sine pi on 6, which will be pi on 6. So 2 theta is n pi plus minus 1 to the n pi on 6. Divide everything by 2. Theta is equal to n pi divided by 2 plus minus 1 to the n pi on 12. Now this is my general solution. And how the hell them getting two things here? These two different functions, it comes from the power n being odd and being even. So for those of you who didn't learn this in school, I'm going to show you what I have to do. Once I get the value of the angle, the general solution, let n be equal to 2p. This is for the even power. So I'm going to get theta is equal to 2p pi over 2 plus minus 1 to the power 2p pi on 12. Now minus 1 to an even power is going to give me positive 1. So the 2's cancel. I'm going to get p pi plus pi on 12. Next, let n be 2p plus 1, which is going to be my odd power. So theta is 2p plus 1, that is n, pi, over 2, plus minus 1 to the power 2p plus 1, pi on 12. Minus 1 to our odd power is going to give me minus 1. So this is going to be 2p plus 1 pi over 2 minus pi on 12. Now we could fix this up depending on the answers that they give us, right? Do we have p pi plus pi on 12, or in this case is n? So we have a n pi plus pi on 12 here. We have a n pi plus pi on 12 here, which means I have to go and fix how this does look. This either simplifies to n pi plus 5 pi on 12 or 2n pi multiplied by 5 pi on 12. Because I have a minus between them there, I am inclined to think that's how it's going to be the first one. Alright, part B. So let me see. Let me expand it out. We're going to get 2p pi over 2 plus pi over 2 minus pi over 12. So I'm going to get p pi or n pi, a half take away 1/12, and hopefully I'll catch on to this. A half take away 1/12 is 5/12 pi. So we're going to have p pi, I'm going to go down a little bit here. We're going to have p pi plus 5 pi on 12 or n pi plus 5 pi on 12. So the answer is B. And this question repeats a lot. Alright, so I just showing you how to get it. In case they bring a different angle inside of here. Instead of pi on 6, they can bring a pi on 3. Alright, so I just showing you how to get the answers. A circle has a center -1, -1. The equation of the tangent to the circle at the point 0, 3 on the circle is, so 0 minus 3, that already is a y-intercept. So I know my y-intercept is going to be -3. Alright? So we have the y-intercepts being -3 for all of the options. So all I had to do is figure out what the gradient is going to be. The gradient is either -1/2, 1/2, -2, or 2. Something that will help me here, just like in my paper 2, is my diagram. Center has minus 1, minus 1. The equation of the tangent to the circle at the point 0, 3, so the one this here, 0, 3. I had to get the gradient of the radius and flip and change the sign to get the gradient of the tangent. So x1, y1, x2, y2. y2 minus y1 over x2 minus x1. 3 plus 1 is going to give me a 0 minus 3, right? And minus 1 minus 1. Yeah. y2 take away y1 over x2 take away x1. Okay. So 3 plus 1 is 4 over 1. y2 take away y1. Yeah. Oh, what? Minus 3. Oops. Minus 3. My bad. So that's minus 3 plus 1 is minus 2 over minus is a plus. Minus 2 over 1, that is gradient of the radius. So I had to flip 1 over minus 2 and change the sign to be a plus. That's my gradient. So I'm looking for the equation that has a gradient of half. The answer is B. The cosine of the angle between the vectors minus 6j and I plus j is, now we can indeed use dot product here. Definitely could use dot product. In this particular scenario, watch this. A diagram might be a little bit easier. Minus 6j, this vector is 0i minus 6j. So minus 6j gonna be downstairs here. So this here is one vector. So I'm just gonna symbolize that vector with an arrow, right? That is one vector D. The next vector is I plus j, which is over here. I plus j. 1, 1. Alright, so if this diagram turn into a right angle triangle, well, my life nice. My life easy. I could go ahead and use trigs to calculate the angle. But the diagram did not turn out to be a right angle triangle, so I'll have to go and use dot product. Not saying that we cannot utilize this and get the angle, eh? We can, but dot product is easier. So let me go into the dot product. We're going to have 0 minus 6 dotted with 1, 1. We're going to get minus 6. Yeah, it's equal to, the size of this is going to be the square root of minus 6 all squared, which is going to give me 6. And the square root of, and this is going to give me square root of 2. Here, root 2. So 6 root 2 cosine theta minus 6 over 6 root 2 is equal to cosine theta. And I'm going to get minus 1 over root 2 is equal to cosine theta. They want to know what cosine of the angle is between the two vectors. This is cosine of the angle. It's going to be minus 1 over root 2. The path of an object is given parametrically as x and y. The slope of the tangent at t is equal to pi on 4 is. Alright, so alright, so dx dt is cosine t and dy dt is minus sine t. dy dx is dy dt multiplied by dt dx. Now I have the x dt. Dt dx is 1 over that. So this is going to be minus sine t multiplied by 1 over cosine t, which is minus tan t. When t is pi on 4, let me see what minus tan t is. So tan of pi on 4, I believe it's going to be 1. Minus tan of pi on 4 is going to be minus 1. So that's going to be the gradient of my tangent. Item 31 refers to the following diagram. From the diagram above, which of the following statements are true? So you see when they give you a diagram, and then they give you things to choose from, and then they combine things to choose from, That is where you had to be real careful. Know what you're doing, then do it. Let me analyze 1. The first derivative at 1 is less than 0. That is f dash 1. This means at x is equal to 1, and I'm putting it into the diagram, at x is equal to 1, the gradient is negative, which means that's how the line is going to be. The gradient is the gradient of the tangent. At 1, indeed, the tangent is negative. So 1 for sure is true. Let's check and see the second one. The function at 1, f of 1 is greater than k. So this is 1, f of 1 here. This indeed is greater than k. So you as well is true. F of 2 is equal to 0. F of 2 is equal to k. So you can be right. So 1 and 2 only are my answers. Alright, the limit as x tends to minus 1. So this is where I'm going to show you guys the L'Hopital shortcut, because paper 1 don't care about working. When you're using L'Hopital, be careful. I see it time and time again. Too much students, too much for me to count. Students will see this and say, that's a quotient rule. No. L'Hopital says, differentiate the top, differentiate the below separately, and then plug in your limit. But this is only going to work if the direct substitution gave us an indeterminate form. So the first thing, religiously substitute the limit into the function and see if you get an indeterminate form. Then you could focus on doing L'Hopital, and I'll prove it to you guys here. When x is equal to minus 1, I'm going to get minus 1 squared, take away minus 1 minus 2. Or my denominator, again, minus 1 minus 1. So my denominator is not 0. So I'm not going to get something being indeterminate here. So the value of this is going to be 1 plus 1 minus 2. 1 and 1 is 2. 2 take away 2 over minus 2. I'm going to get 0. Now, if I used L'Hopital, this is how I'm going to use it. I'll differentiate the numerator, 2x minus 1. Then I'll differentiate the denominator to just get 1. Then I'll plug in the limit. So I'm going to get 2 into minus 1 minus 1. And this is going to give me minus 3. So you see how the question gave us an option as minus 3. I commend CAPE for doing this, because they will now, they're thinking ahead of the students. Students going to use L'Hopital for this without even substituting the limit inside and get minus 3 as the answer, which is going to be wrong. My initial substitution did not give me something that's indeterminate, so I cannot use L'Hopital's rule for number 32. Alright, next, number 33. The function g is defined as g of x is equal to 3p plus 2 over 3x minus 1. X is less than 3, x is greater than or equal to 3. For the function to be continuous at x is equal to 3, the value of p should be, well, the left-hand limit should be equal to the right-hand limit, and it should be equal to the value of the function at the point itself. So, the limit as x tends to 3 from the left must be equal to f of 3, and must be equal to the limit as x tends to 3 from the right. If I turn it to 3 from the left, I'm using this. So I'm going to get the limit as x tends to 3 of 3p plus 2 must be equal to f of 3, which is going to be this here. 3 into 3 take away 1, which is equal to, if I turn into 3 from the right, I'm using this same limit here. So I don't need to put this in here. So all I need to do is have 3 into 3, 3p plus 2 must be equal to 3 3s are 9. 9 take away 1 is 8. So 3p must be equal to 8. Take away 2, which is 6. And p must be equal to 2. Given that cosine 2x is equal to 2 cos squared x minus 1, then cos squared of x on 4. Alright, so all I'm gonna do, instead of x, I change how x does look. I'm gonna put x is equal to x over 4. So I'm going to let x be x over 4. I'm going to get cosine of 2 into x over 4 is equal to 2 cos squared x over 4 minus 1. I want to get the integral of cos squared x over 4, so I'm going to have to do a little bit of rearranging. So let me move the minus 1 across. U and U go cancel to give me 2. The 1 comes across to give me 1 plus cosine of x over 2. And I'm dividing each of these terms by 2, divided by 2, divided by 2. And I want the integral of this side, which means I have to integrate this side. And when I integrate in this side, I can split up the integral as the integral of a half plus the integral of this. The integral of a half is a half x. So we sort out that piece here in the beginning. Everybody have a half x. This one gonna be plus 1/2 the integral of cosine x on 2. Plus 1/2 the integral of cosine of x on 2. The answer is going to be d. If y is equal to this, then dy dx is... Now this is a skill I want you all to learn going into Unit 2. Learning how to do the product rule and the quotient rule mentally without writing any statements is very important. And no is u on top and v below, for those of you all who know how to write your statements. Dy dx is going to be v by du dx, which is 1, take away u multiplied by the v dx, which is minus 4, all over v squared. I'm not going to put all over v squared because I glanced at all 4 options. All 4 options have the same denominator, which is v squared. So I'm just focusing on my numerator. Expanding 3 minus 4x, minus and a minus is a plus, plus 4x, 4 multiplied by negative 6 is minus 24. U and U go away, 3 take away 24 is minus 21. The answer is E. A rod is heated and its length at time t seconds is given by L is equal to 5t squared plus 100. Alright, so its length at t seconds. So L is in terms of t. When t is equal to 3, the rate of increase of L. So we want the rate of increase of L, which is dL dt. That is just 10t. When t is 3. Right to t. Well, well, well. All back and no bite in that question. Alright, that's all we needed for the question, dL dt. Aha! Look, we have the first taste of L'Hopital here. Alright, I am going to do the cancelling and I am going to do the direct substitution as well, and I'll use L'Hopital, okay? So directly substituting, I will get 3 minus 3 in the denominator, well, bacchanal. It indeterminate. The numerator, however, is a difference of 2 squares, x minus 3 into x plus 3 over x minus 3. U and U cancel, plug in 3, 3 plus 3 is 6, so 6 is my answer. Or I can use L'Hopital and differentiate the top to get 2x, differentiate the denominator to get 1, and then plug in the limit. 2 into 3, and we get 6. If the integral between 4 and 2 of f of x dx is 12, what is the value of the integral between 3 and 2 plus the integral between 4 and 3 of f of x take away 1? Alright, so 2 things are going to change here. Well, let me change one thing at a time, right? The integral between 3 and 2 of f of x, I'm not putting in the dx, plus the integral between 4 and 3 of f of x. Take away the integral between 4 and 3 of 1. Cool? A little bit more on that. Now I'm going to show you all, for those of you all who probably ain't know, I'm going to show you something cool. When it comes to integrating, if this is a function f of x, right? And I have a, b, and c. The area, this whole big area here, is the integral between b and a of f of x dx. That's how I calculate that area. I can also split up that area as this area plus this area. So this integral is actually equal to the integral between c and a of f of x dx plus the integral between b and the c of f of x dx. Now, when we have the same function to integrate, and my limit on top in one integral is the limit below in the next integral, like what we have over here, I could combine those two integrals, keep my upper limit as the bigger number, keep my lower limit as the smaller number. So, brethren, here, these two things can now combine to be the integral between 4 and 2, which is what we get above, 12. Take away the integral between 4 and 3 of 1. So I'm going to get 12 take away something. So I know D can be the answer. Let me check and see what this is now. That is, when I integrate x, I'll get, well, when I integrate 1, I'll get x between 4 and 3. 4 take away 3, that is 1. 12 take away 1, that's going to be 11. If the second derivative is 6x, I'm going to take off this. Given that the first derivative at 0 is equal to 0 and c is a constant, f of x is, okay. So if I go do statements here, f double dash x is equal to 6x. Is equal to 6x. When I integrate and I integrate, again, f dash x is 6x squared over 2, which is going to give me 3x plus c. They say that how this happening. So f dash 0 is 3 into 0 plus c. And they say that our f dash 0 is 0. So 0 is equal to 0 plus c. And I get c to be 0. So f dash x is equal to just 3x. Integrate again, integrate again. I go get f of x is 3x squared over 2 plus k. Never given nothing else to calculate the constant. Well, in the question, the constant is c, so I just changing k to c. So looking for 3x squared. Oh no, this is 3x squared, sorry. So 3x cubed over 3 will be x cubed plus k. X cubed plus c, the answer is D. Right, my little mistake there, I forgot to put in the squared. Okay. The integral between pi and 4 of sec squared x is equal to. Now we can use something called integration by recognition here. We know that when I differentiate tan x, I get in sec squared x. So d dx of tan x is equal to sec squared x. So when I integrate both sides, I'm going to get tan x is the integral of sec squared x. So I'm going to get tan x between pi on 4 and 0, which is just tan of pi on 4, take away tan of 0. Tan of pi on 4 is 1. Tan of 0 is 0. The answer is A. Right, but I don't want to be too sure. I not no hero. Tan of pi on 4. Make sure your calculator is in radians. That is 1. Tan of 0 is 0. Now we're safe. Number 41 refers to the following diagram. The gradient of the normal to the curve y is equal to ln x at x is equal to 2 is, well, we had to get the gradient at the tangent first. So y is equal to ln x. dy dx is equal to 1 on x. At x is equal to 2, the differential is a half. This is the gradient of the tangent. The gradient of the normal go say, hey, flip this and change the sign. So I'll get 2 with a minus 2. So this here is the gradient of tangent. Aha, our rates of change. The radius of a circle is increasing at a rate, so dr dt 0.1. When the radius is 3, the rate of increase of the area, the ADT, is the RDT multiplied by the ADR. Well, A is equal to pi r squared. The ADR is 2 pi r. 0.1 multiplied by 2 pi, and let's say when the radius is 3. 3 2s are 6. 6 by 0.1 is 0.6 pi. And 0.6 is 5/6. 3/5, sorry. Yeah, 0.6 is 3/5. Yes. 3/5 pi. Item 43 refers to the following diagram. The finite region R is enclosed by the curve y is equal to x squared. The y-axis, the line y is 3, and it is rotated completely about the y-axis. So when I rotate in about the y-axis, the volume is going to be the integral of pi x squared dy. So I'm looking for a dy. So them is the only two things that can work. Alright, the limit's going to be 3 and 0. In this case here, x squared is y. So if x squared is y, the integral pi y dy is my answer. Pi y dy. D. Alright, so again, indeterminate. Differentiate the top. 3x squared. When I differentiate 2 cubed, again 0, that is a constant, that is just 8 over 1. Plug in x is equal to 2. 3 into 2 squared. 3 into 4, and again 12. Bam, shot are done. The gradient of the normal to the curve at x is 1. Let me differentiate. Y prime is equal to 3x squared. I'm going to get 6x minus 2. When x is 1, I'm going to get 6 into 1 minus 2. 6 minus 2 is 4. Flip it, I get a quarter. Change the sign, I get minus 1. And we take an hour and 13 minutes with a lot of explanations to finish the first year we are going to do.